Hi everyone, welcome back to ITAP 2021 Industry Connect Talks at the Singapore Government Pavilion. My name is Royston and I'll be your MC for this session. So this session will be on the next wave Agritech, something very close to our hearts as it involves the creation, the nurturing of food and its supplies in Singapore as well as with the international partners we have. We have lined up 3 speakers today, as well as a video recording on this topic. Without further ado, let me just introduce what the first video recording will be about. It will be from Dr. Hazel Khoo, who is the Executive Director of the Singapore Institute for Food and Biotechnologies, or SIFB for short, who will give an overview of the Singapore food story and what A-Star is doing in this area of agri-tech and aquaculture to kick things off before we pass it on to 3 speakers who will share more about their work in this area. So with that, could I have the first video on?
Good afternoon, everyone. My name is Hazel Khoo. I am the Executive Director of the Singapore Institute of Food and Biotechnology Innovation, as well as the Agritech and Aquaculture Horizontal Technology Program Office. It gives me great pleasure this afternoon to give you a few preamble remarks to kick off the session on the Industry Connect Agritech. As some of you may know, ITAP brings back very fond memories, as I've been personally involved in the organization of the 2 events. So it is really an honor to be part of the ITAP community this afternoon. This slide conjures an image of food as a national pastime in Singapore, which is probably not too far away from the truth. But let us zoom out to have a global outlook of the food and ingredients sector. Some of the global shifts affecting the food industry. First of all, population growth. As many of us may know, that the population is forecasted to grow up to 9 billion in the year 2050. And amongst this is a rising Asian population, as well as an emerging size in terms of the middle class, as well as the aging population. And due to climate change and the increased incidence of disruptive events, there have been incidences of declining agri-food yields. And coupled with the urbanization of agricultural nations, we are seeing also a greater emergence of urban indoor farming. Against this context of the global shifts, we are also seeing a set of global food trends, first being future foods, particularly in alternative proteins. We are seeing in the market an advent of plant-based proteins, and in fact, coming to the market is also the cell-based meat product. There's also a greater demand by the consumers for better and more nutritious food, as well as foods that are produced more sustainably. And finally, in the last 20 months or so, many of us have seen the impact of the COVID-19 pandemic, and that requires many countries across the world to really look at our food security plans. Likewise, in Singapore, we have been making plans for our food security, not just as a result of the COVID-19 pandemic. In year 2019, we actually launched the Singapore Food Story, and here on this slide, we see 3 food baskets. First of all, and top on the list is actually diversifying our import sources so that we are not reliant on any one source. Second is about growing locally, and here we launched the Singapore Food Story R&D program 2 years ago, and it is with the aim of producing 30% of our nutritional needs locally in Singapore. And with this growing locally strategy, we are also complementing it with a growing overseas, where local producers are encouraged to extend into overseas for their food production and then to eventually bring products back into Singapore. So in 2019, the Singapore Food Story 30 by 30 goal was launched with a $144 million of R&D funds injected by the Singapore government. Under this Singapore Food Story R&D program, there are 3 thrusts, the first being in sustainable urban food production, and the second is in future food, and the third is to have a framework for food safety science and innovation. Under the Agritech and Aquaculture Horizontal Technology Program Office, we have 4 R&D pillars, and they are in the areas of locally adapted, high-yielding inputs and species, second on health monitoring and disease management, third on precision agri and intensive aquaculture, and finally on digital twin, smart and sustainable farming system. As you can see, within the R&D programs reflected in the bottom half of this slide, many of the capabilities are in the areas of automation, robotics, AI, data analytics. Many of these technologies are relevant conversations as part of the ITAP event. Within the A2HTPO, we have been supporting many Agritech companies through R&D for their innovation. And two programs that we have funded are in the areas of precision and agriculture and robotics, as well as hybrid lighting and technology. So on this note, it gives me great pleasure to hand over the stage to the researchers that have been working on these two research programs, Gary, Kensu, as well as Urano, to brief us on the update on these two research programs. Thank you.
So we'd just like to thank Dr. Hazel Koo for that sharing and the introduction to what we do at A-Star in this area. So at this point, let's invite our three speakers to share more on Agriculture 4.0 in A-Star. First up, we have Dr. Gary Ng from Simtech. Dr. Gary, please.
Thank you, Royston. Hello, everyone. Good afternoon. My name is Gary. I'm from A-Star. And today, I'll also have my fellow speaker, Mr. Ong Kian Soo and Dr. Daisuke, who will share about the research programs they are leading. So the title of the talk is Agriculture 4.0 and how technology can help us. So back in 2015, United Nations declared sustainable goals, right? And the 17 sustainable goals. And the second goal is about ending hunger by 2030 to achieve food security and improve nutrition and promote sustainable agriculture. So take note that agriculture contributes quite a portion to greenhouse gas emissions as well. So some of the approaches recommended will include investing in agriculture research and developing sustainable and resilient production system using technology, right, to increase productivity and production. As the previous speaker have highlighted, the agriculture industry is facing challenges due to increasing population. There's greater demand for more food, and also urbanization, right? People wanting more processed food, and also probably more protein, more meat. And as people move to urban areas, who's going to do the farming in the rural areas? The stress natural resources is a challenge as well, right? So we are depleting good farmlands, soil erosions, and also water is getting scarce, right? So back to Singapore, we have our Singapore food story as well. So Singapore, as we develop as a small nation with very little land, currently we import over 90% of our food from overseas. Although we try to diversify our food. And as in 2018, 13% of our vegetables are locally grown, and 9% of fish, and 24% of eggs. And this presents a food supply and security issue, right? What if there will be outbreaks of food disease in countries that we import food from, or closing of port, right, in countries that we import the food from, or there could be political changes. And COVID-19 also shows that diversification of our food sources cannot be the only strategy, right? So in Singapore, we have a 30 by 30 goal, right? So that is to build up our Agritech industry capability and capacity, right? To increase, to produce at least 30%, right, of our nutritional needs locally, right, and sustainability. Also by the year 2030, right? All in all, with within the land constraint of less than 1% of all Singapore land available for farming. So we're going to leverage technologies, right, for urban farms, right? So using technology is possible to be highly productive, up to 10 to 15% of our traditional farm. And of course, with urban farm, we want to make it climate resistant as well. And that is also one of the challenges to the agriculture industry, right? The changing climate weather conditions and extreme weathers. And also, with the technology, we can be more sustainable. And last but not least, we want to be land and resource efficient, right, in applying technologies to our farm. So what are some of the technologies for agriculture 4.0? So on the top, you can see the typical process, right, for farms, right, that plant leafy greens, right? You start from seeding, then undergo germination, and then growth before you harvest and package. So some of the technologies could be in climate control, right? Especially if you move into indoor farming, right? You need to control the temperature, the humidity, and also the gases, right, within the indoor environment, right? Especially for the growth stage. And also in Singapore, the labor is very costly, right? So we want to use automation and robotics, right, to apply to the farming. And that has a lot of applications. In fact, throughout the whole 5 steps over there, from seeding all the way to packaging, right? One of the vision is to go manless, right? The entire farm, all the activities, we do not require human. The third one could be lighting technology. As we know, plants need light to grow. So how do we have efficient lighting technology, right, to supply to the farm, right? How do we use a good combination of natural and also artificial lighting? And of course, sensors, IoT and analytics, they go together, right? We need sensors to monitor the plants, the nutrients, the environment, right? And then link everything up to the internet, and of course, process the data using AI and analytics. Precision agriculture is important as well, right? This is where we want to understand more about the plant science, right? And then how do we ensure we can grow more with less, right? How do we optimize the nutritional value, the yield, right, of the plant with a lower amount of input? And of course, vision and imaging is important as well for monitoring the plant that we are growing. So next, I'm going to hand over to the presenter, next presenter, Mr. Ong Kian. So he'll talk about the sustainable lighting system. And following that, we'll have Dr. Daisuke on the HIPAA program. Thanks.
Hello, good afternoon, everyone. Yeah. So what I want to do, I'm Kensu from A-Star, and I want to talk about hybrid lighting system that we are developing. All right, as you see from the slides, what we are doing is actually looking into various aspects. How can we save energy while using the artificial lighting? And how can we tap the natural sunlight because it's free? And from there, we are able to reduce the energy used in artificial lighting. So this is what we're going to, later I'm going to talk about it. But before I go on, I think you have here our Dr. Hazel Cole mentioned about food security, and also Dr. Gary talking about how we can achieve from the industry 4.0 by putting every aspect of the farming and put in the AI, automations, energy savings, sustainability, and also how can we make the farming more effective. So this is something that the whole picture that A-Star Food Story is going to plan for, together with Singapore Food Agency, together with ESG and various agencies. So what we want to do is, now I want to show you all, beside all the AI, automation, you also need to know what is the science and technology behind all these operations. If you know how to save the energy, you are able to actually reduce the cost of your operation and also improve your yield of the plant growing and also reduce the plant growth cycle. In this case, you are actually able to produce it more effectively. All right. Okay. So in my program, I have 3 work package. One is actually the hybrid lighting. The other one is sunlight manipulation and then also energy saving LED. The sunlight manipulation is actually more toward the greenhouses that we can actually more effectively make use of the sunlight. I think everyone who are see a farm, they know that for greenhouse, you normally can have only single tier. You can't have multiple. If you have a tower, you need to be spaced far away because the sunlight will cast shadow to other farms at the different timing of the day. So what we are trying to do is want to reduce this impact of the shadow of the sunlight and reduce the gap between the towers of the plant grow area so that you can produce more and within the same footprint. And the other one we can talk about is the tuned lighting. We can actually tune the LED spectrum based on the spectrum recipe that the farm want to grow from their plant. So in other words, you don't need to be restrictive to just blue or red LED. We can actually provide a wide range of very, very narrow spectrum that are suitable for your plant growth. For instance, some company may want to grow more to harvest the proteins or the anthocyanins and things like that. So they all require different wavelength in order to increase the production of those chemicals. So we are able to do that. And then in the LED part, we actually work on the quantum dot material that able to convert blue light to different wavelength. For instance, green, yellow. As we know, the green, yellow light, they are very low in quantum efficiency. So by using a blue LED, which have a higher quantum efficiency, we are actually producing yellow and green light with a better this so-called power efficiency, and hence we can save our 20 to 30% of energy used for the LED lighting. Right? And this slide look a bit complicated, but it's actually what we are going to do. We actually mix up all the different technology so that similar technology that can enhance the fund growth or enhance the energy saving, we will put them together. For instance, at your left, you can see that I have a thermal electric cooling system and work together with the quantum dot color converter. In this case, we can reduce the temperature of the LED panel and hence expand the lifespan of the LED panel and also improve the energy consumption. And then at the bottom side, you can see that there is a complicated message, but this is later I will come to that again. It's actually our sister RI from Simtech that they developed grow tray that able to provide better circulation of the nutrient, and hence we are able to control the microclimate such as temperature, carbon dioxide, humidity better, and that will able to save more energy from the aspect. Right? And on your right side, you can see that we have the electrochromic panel, but this is very different from what in the market. We are able to control the visible light and the sunlight without using any external energy source. And we also able to focus the light better to the plant using this method. We will develop it as we go. And then on top of it, you can see that yellow light is coming from the side. So imagine this is in the greenhouse, and we are able to bring the sunlight to the middle of the rack. In this case, you are able to have another rack on top of it, and so on. So this will greatly improve the yield and the use of the land in the greenhouse, especially in case of Singapore. And on top of it, you can see that we have a NUS calibrator that they actually look into the lighting spectrum. By doing that, they are able to say, okay, which spectrum is better for leaf growth, which spectrum is better for the stem growth, and so on. So by doing that, we are able to come out data. And all this data will be very useful to put into the platform where we actually going to we are going to actually create a platform that you are able to select your seed, your grow condition, and when you want to harvest, and even the infrastructure of growing all these plant in your facility. So this is a plant growth model at the end of the day we want to provide. And with all this together, we are able to save about 40% to 80% of energy consumption together. The trick is, if you use just one technique, you only can save certain percentage. There's a limitation that you can save more energy from there. But when you combine with a different technology and save the energy at different angle, at different location, and different condition, you are able to bring them all together, and then you save more energy. How to do it? That's where the Agritech 4.0 will come in. Because you will need sensors, you need to have this algorithm of looking at the data, at the machine learning, and so on. So this is where all this work in A-Star are putting together to make sure that we have a energy saving solution for the Agritech operators, and also we look into what are the technology suitable for it. Okay, so this is the approach that what we do. We have a design and simulation team from Institute of High Performance Computation, and they actually help us to reduce the try by error step. By doing all the simulation and the design, we are able to select the best solution and go for the manufacturing, the productization, and we are welcome industry players, IHL, to work together into the integration and of all this technology, and then we can actually put them apply on the farm. Okay, this is the one of the technology that we are going to showcase in our booth, and later you all can have a look at it also. But what we have done is we have able to reduce the temperature of the LED from 60 degree to 29 degree or 25 degree. By doing that, we actually improve the lifespan of LED and also reduce the energy consumption. And our quantum dot LED, as you see from the left, from your right, you can see that the left side is your right side is actually a standard LED, but on your right you can see that it actually have the different colors, and this is how we actually convert a blue LED to a different color spectrum. So in doing that, you can have just a very simple LED, and then you can achieve different wavelength as you using the color converter. And this color converter also in future will come with a diffuser, and we are able to reduce the gap between the lighting to the plant. So it means that you can have more tray to grow your plant, and then the productivity will improve further. And this is also shown in our booth, where we have a system that we are able to make use of nutrient solution to control and regulate the temperature and humidity of the racks. By doing that, we are able to reduce the energy used from the air conditioning, right? So you are able to run the operation in a more energy effective way, right? And besides the nutrient control, the temperature, the system, microclimate control system, also able to measure the temperature change, the humidity change, the carbon dioxide concentration, and so on, so that there is only one touch for you, for the operator, to adjust the condition. And also the document are allowed the learning process, and eventually they are able to manage your plant growth production automatically. So you can just sit back and relax. Okay, so this is the example that the that we show in demo we show in the booth. You all can also have a look of it. All right. With this, I would like to Daisuke, Dr. to come in and talk about more on the hybrid HIPAA system that he has.
Thanks, Kiansu. As the last part of this session, I want to introduce another Agritech program supported by the Singapore government. It's called High Performance Precision Agriculture. So we have 3 institutions involved in this program. The first one is the Temasek Life Science Laboratory that contributes to the biological solutions for vertical indoor farming, urban farming. We also want to propose some engineering solutions that will be covered by the A-Star. Then the last party in this program is the NUS, Computational Science, which provides AI, machine learning expertise to us. So this program is designed to encourage academic industry collaborations to innovate the new technologies like robotics for the automation of the indoor farming, then also LED, efficient LED lighting. So LED is the core part of the indoor farming because that's a replacement of the sunlight. So another company, another industry we are collaborating is sensor technology, more like the new computer vision to replace indoor farmers. The last part is the AI company. So that is the brain of this program. So we have 4 different areas focusing on. The first part is the biological solutions. Vegetable breeding, screening, we are contributing to. So nowadays, all of the indoor farms use vegetable varieties, seeds, that were originally optimized for outdoor farm because indoor farm market, indoor farm technologies didn't exist 10 years ago. So no market, so that means no optimal varieties for the indoor farm. So we are using the new advanced molecular engineering technique to improve or to add some specific traits to the existing seeds. So that is the first program. Second one is the AI, machine learning and optimization. So using massive amount of data collected from our pilot indoor farm, we will optimize indoor farming recipe, growing recipe of the plants in the indoor farm setting. The AI can find the optimal conditions effectively. But to use the AI effectively, we need the data. So we need standardized setting, how to collect the data more efficiently. To this end, we need some optical sensors. A-Star, IBB, our colleagues in the A-Star will be developing the multiple optical sensors that can collect the data much better than our human eyes. The last part is the automation, robotics. So some part of the indoor farm agricultural productions have been already automated, but not the all. So in our program, as I show on the right, we are developing robot end effector that can handle like the soft material, like like vegetables or some other fruits, of which physical property is quite soft and inconsistent. So that's another part covered by the A-Star colleagues. So from this academic industry collaborations, we want to develop and also commercialize in the end new sensors that can be used for the agriculture. Also like agrochemicals, I didn't explain, but this is not like the conventional fertilizer, herbicide, insecticide. More the new type of the agrochemicals that can change, manipulate some specific traits in the plants, like the leaf color in the leafy greens, or to increase functional compounds. Then also robot. Then now we can use the AI if we had the big data. So that means we need the database. to have to use the AI efficiently. So we want to have the database and also in silico simulated database. So that in the future, we can just type the conditions of the temperature, light intensity, nutrient concentrations. Then farmers can easily know how many days they need to cultivate and what's the commercial value they can get from that condition. So that will help the indoor farmers in the future a lot to choose which one they should grow. Then the last part is the new cultivars from biological program. So I list here some of the challenges many of the indoor farmers face currently, then our solutions. So this is the very rough cost distribution of indoor farm agricultural produce. The three major parts you can see, the first one is the energy, the lighting, LED, and air conditioning. The second big part of the cost is the labor and logistics. The last one is the facility. So to make the indoor farm business sustainable, consistent, we need to reduce the cost, this part, while increasing commercial value of the agricultural produce. So to increase the commercial value of the agricultural products, we are proposing to improve the seeds. So the seed costs only less than 1% of the total production cost. But usually the improvement of the seeds, the traits of the plants, takes long time. That's the, the breeding program. Takes like the years. But once we get the new seeds that have the better traits, that can directly contribute to the profit margin. So our goal, we are trying to make the new seeds that can provide more biomass with less energy inputs. So that's the first program. I will explain a bit later. The second, to reduce the energy, like the lighting, for example, we propose to use the AI. So for example, what we know as the plant scientist, seedling stage, the young stage of the plants need lower light intensity to grow nicely. But at the mature stage, just like 2 weeks before the harvest, they need more light. But usually the light intensity, we change, but not that optimally. So by understanding, by correcting how plant grow, that kind of plant data continuously, combined with the environmental parameter data, the AI can find what's the optimal lighting condition in this case to maintain the plant growth rate while minimizing the energy input. So that's our second solution, to cut the cost. The last part is the more automation. So again, some part of the indoor farm have been already automated, not the all. Still, indoor farmers need to walk around the indoor farm every day to check plant health status, how they are growing. So we are developing the new type of optical sensors to replace the indoor farm operators. We aim to make, in the end, fully automated management system for the indoor farming. So I will introduce the sensor development part as well. So this is a slide explaining more like the biological solutions. So to find, in this case, like lettuce varieties suitable for the indoor farming, we are taking two different approaches. The first one is called cultivar screening. So there are hundreds of the different cultivars already developed by the farmers and breeders. Some of them became really popular, maybe because they have the traits like pathogen resistance or stress resistance, like the drought resistance. But some other seeds that may grow nicely in the indoor farm setting may not be popular just because they are not resistant to the pathogens, for example. But those traits are not important for the indoor farming. So by using the indoor farm setting, so in this case, I use like 28 degree and also low light intensity suitable for the indoor farming to screen out the best variety, the suitable varieties from the pool of the existing lettuce varieties. So that's one of the approach to find the best variety for indoor farming. The second approach is more challenging, more aggressive. So we can use new technology called genome engineering to add any of the traits we want to the existing varieties of the vegetables or whatever the crops. So if we had some, in this case like the lettuce, that can grow nicely in the indoor farm, but the taste is not nice or commercial value is not that high, for example, we can increase amount of the functional compounds, vitamin, and mineral contents. We can add that trait to the elite cultivar. Instead, if we had the cultivars consumers like, but not grow nicely in the indoor farming, maybe because of the warm temperature resistance or low light resistance, we can add that specific traits using this called genome engineering, CRISPR-Cas9 technology. Good part, this is not the GMO in general. So this is the last slide. I want to introduce the sensor project as well. There are so many optical sensors available in the market. The cheapest one is the RGB imaging. Using our cell phone, we can take a picture of the tomato like this, and also the leaf. As you can see, using the color, red color, we can know, okay, so now the tomato is matured. From the leaf, you can see some dark spots. Experienced farmers can know, so now the tomatoes are infected with the bacteria, some specific types of the bacteria or fungi. But using this technology, what I'm showing here is called Raman spectroscopy that can detect the vibration of the chemical bond of any type of the molecules. We can detect, for example, in this case, one of the carotenoid called lycopene. So this is the Raman spectrum from the pure lycopene powder. The top, I'm showing the 3 different spectra I got from tomatoes, individual tomatoes. So by comparing this spectra, the height of the peaks with that one, we can estimate how much lycopene carotenoids accumulated in the tomato. So this one can be used as the quality control of the agricultural produce. The second one I'm showing here is fluorescence technology. Many of the plant pigments, like anthocyanin, so that is another antioxidant, and chlorophyll, show nice fluorescence in the visible light range. So we are developing a new fluorescence imager that can detect chlorophyll activity at the same time the anthocyanin amount. So this one already, we finished the development and we submitted for the publication. In the end, all of the sensors will be integrated into that small probe so that we can get all of the comprehensive data from the one set of the experiment. So this will be used to replace the experienced farmers in the indoor farm or other urban farm, high-tech farm settings. So this is the last slide of our talk. Agriculture 4.0 and technologies is our answer to revolutionize the agriculture and to solve the problems with food production. So Kiansu introduced innovative lighting and climate control solutions that will help solve the energy issues in the farming. The precision agriculture I presented now will be the key to improve the yield and nutritional values with less energy input. So our take-home message is grow more plants with less input, less energy. So this is the end of the talk. So if you have any questions, If you are interested in any of the parts in our talk, please let us know. Our programs are designed to encourage industrial collaborations. Both of the Kiansu and I are quite open to make the new collaborations. So if you are interested, just email or just find us after the talk. Thank you.